The James Webb Space Telescope is not just another space observatory, it is a masterpiece of human ambition, an engineering marvel decades in the making, and a symbol of our relentless pursuit to understand the cosmos. This extraordinary scientific instrument took more than 25 years to develop, requiring pioneering technology, countless breakthroughs, and an unwavering commitment from scientists and engineers across the world. For those who have dedicated their lives to unraveling the mysteries of space, JWST represents the fulfillment of a dream, one that seemed impossible at times. As the saying goes, it took a series of miracles to bring it to life. And now, this technological wonder is rewarding that patience with breathtaking images, and discoveries that are rewriting the very story of our universe. Since its launch, the James Webb Space Telescope has been capturing light that has traveled through space for over 13 billion years. This means that every image Webb provides is essentially a window into the past, offering us an unprecedented glimpse of the universe as it existed when it was still in its infancy. The possibility of seeing the first galaxies ever formed, of witnessing the birth of stars hidden in cosmic nurseries, and of exploring distant exoplanets with unimaginable detail is enough to ignite the curiosity of anyone fascinated by the great unknown. The telescope is often referred to as the successor to the Hubble Space Telescope, but calling it a simple replacement would not do it justice. Webb is not just an upgraded version of Hubble, it is an entirely new breed of telescope. While Hubble primarily observes the universe in visible and ultraviolet light, Webb is designed to see the cosmos in infrared. This key difference allows it to peer through dense clouds of cosmic dust that have obscured our view for centuries. With its advanced infrared capabilities, Webb can uncover hidden structures and celestial objects that have remained invisible until now, forever changing our perception of the universe. To achieve its groundbreaking capabilities, the telescope required a mirror far larger than Hubble's, one that is 7 times its size. This massive mirror, composed of 18 gold-plated hexagonal segments, allows it to collect more light than any telescope before it. The more light it collects, the fainter and more distant objects it can see, pushing the boundaries of exploration further than we ever imagined. With this revolutionary upgrade, JWST is capable of making discoveries that could redefine what we think we know about the cosmos. The journey to bring JWST to life was filled with challenges. Developing a telescope of this magnitude was no easy feat, and the process was plagued by delays, budget overruns, and complex engineering problems that had never been solved before. Unlike Hubble, which orbits just 547 kilometers, 340 miles, above Earth and has been serviced multiple times by astronauts, Webb had to be placed much farther away at the second Lagrange point, L2, nearly 1.5 million kilometers, almost 1 million miles, from our planet. At this distance, repairs or upgrades would be impossible. Every single component had to work flawlessly on the first attempt. The moment of truth came on December 25, 2021, when Webb was launched aboard an Ariane 5 rocket from Europe's spaceport in French Guiana. Even after the successful launch, the telescope's mission was far from secure. Over the following weeks, Webb had to execute one of the most intricate and high-stakes deployment sequences in history. The telescope's mirror had to unfold precisely, its 5-layered sunshield, designed to block heat from the sun, had to deploy perfectly, and hundreds of moving parts had to function with absolute precision. Any mistake could have meant disaster. But against all odds, everything worked. By late June 2022, the James Webb Space Telescope was fully operational and ready to begin its mission. What followed was nothing short of extraordinary. Within days, Webb captured its first deep space images, revealing a universe brimming with thousands of previously unseen galaxies. Some of these galaxies dated back to just 150 million years after the Big Bang, breaking all previous records for the earliest objects ever observed. One of the most astonishing abilities of JWST is its power to analyze the chemical makeup of objects light years away. By studying the way light interacts with different materials, scientists can determine the composition of distant stars, galaxies, and even planets. This ability has already led to some of the most exciting discoveries in recent history. Perhaps one of the most famous images captured by the Hubble Space Telescope is the Pillars of Creation, a mesmerizing structure located in the Eagle Nebula. These towering clouds of gas and dust, over 6,500 light-years away, are stellar nurseries where new stars are born. However, Hubble's images of the pillars, while breathtaking, were limited in what they could reveal. Because Hubble primarily captures visible light, the dense clouds of cosmic dust obscured much of what was happening inside. Webb, with its infrared vision, has changed that. By piercing through the dust, it has unveiled never-before-seen details within the pillars of creation. For the first time, we can now see the very moment when stars begin to form inside these towering structures. Among the most fascinating discoveries are the numerous red dots, scattered throughout the image. These are protostars, young stars that are still in the process of accumulating mass. Protostars are fascinating objects because they represent the earliest stage of a star's life. Before they can ignite nuclear fusion, the process that makes stars shine, they must first gather enough mass and heat to reach millions of degrees in temperature. Once they do, they officially become fully formed stars, shining brightly for millions or even billions of years. Webb's images, enhanced using false color processing to help us visualize infrared light, reveal these incredible celestial events in stunning clarity. While Webb is revolutionizing our understanding of star formation, it is also changing the game in one of the most exciting areas of modern astronomy, the search for exoplanets. Since the 1990s, astronomers have discovered thousands of exoplanets, but actually seeing them has been incredibly difficult. The reason for this is simple: exoplanets are often overshadowed by the overwhelming brightness of their host stars, making direct imaging almost impossible. Instead, scientists have relied on indirect methods, such as the transit technique, where they observe tiny dips in a star's brightness as a planet passes in front of it. In September 2022, JWST achieved what was once thought to be impossible: it directly imaged an exoplanet. This planet, known as HIP 65426b, is a massive gas giant that is over 12 times the size of Jupiter. Unlike previous detections, Webb was able to capture this planet using its coronagraphs, which block out the bright light from its star, allowing the planet's faint glow to be seen. HIP 65426b is a behemoth of a planet, orbiting its star at an enormous distance, 100 times farther than Earth orbits the Sun. This massive gap made it an ideal candidate for Webb's direct imaging capabilities. The data gathered from this observation has already provided scientists with new insights into the composition and evolution of gas giant planets. One of the most astonishing findings to come from JWST is the discovery of water vapor clouds in the atmosphere of an exoplanet. WASP-96b, a hot Jupiter orbiting extremely close to its star, was found to have a complex and dynamic atmosphere. Though its scorching temperatures make it inhospitable for life as we know it, the detection of water vapor has intensified the search for habitable worlds. If there is one thing that excites scientists the most, it is the possibility of finding signs of life beyond Earth. Many researchers believe that the presence of methane in an exoplanet's atmosphere could be a strong indicator of biological activity. On Earth, the vast majority of methane is produced by bacteria, meaning that if we were to detect large amounts of methane elsewhere, it could suggest the presence of alien life forms. With each new discovery, the James Webb Space Telescope is redefining our understanding of the cosmos. Every image, every spectrum of light it analyzes, and every distant planet it studies brings us closer to answering some of the most profound questions of our existence. Are we truly alone? Or is there another civilization, far beyond our reach, looking back at us, asking the very same questions? Subscribe to our channel for more mind-blowing space discoveries, and thank you for watching. Rocket.